Hello everyone, welcome once again to Sailor Space, the Engineer and Navigators Hub. I hope you get a lot from today's session. Today we're gonna look at a very simple illustration. I'm gonna use this diagram to explain the types of pumps we have in a fuel oil system on board a ship and what those pumps are doing there, what's their function. If you have 3 or 4 pumps, how can you differentiate them? How can you explain them based on what they do? So basically we have 4 types of pump in a fuel oil system. So in this diagram, you would see that we have 3 types of pump. That's the supply pumps, the circulating pumps, and we have the fuel pump towards the engine axis. That's the main engine. There's a mission of one other pump. That's the transfer pump. So basically, we have 4 different pumps in a fuel oil piping system that aids the flow of fuel from point A to point B. Alright, moving forward. What is a pump? How can we explain a pump before we can now know the different descriptions of pump in a fuel oil piping system? A pump is basically a mechanical device that moves fluid from one point to other, that transfer fluid, whichever synonymic word you want to use there. It moves fluid, whichever fluid. But in this case, we are talking about the fuel. We're talking about fuel oil. So that's, in this context, a pump is a mechanical device that transfers fuel oil from one point to another in the system. Okay, so using a layman language, how can I describe a pump? Okay, if I have water in a bucket and I want to move that water from the sitting room to the kitchen, the water will not move itself. It does not have legs. So basically, the human being that moves that water, either by carrying it or scooping it from the sitting room to the kitchen, basically becomes the pump. You've transferred the water from the sitting room to the kitchen. So now when you receive fuel from your bunker batch or from your supply vessel, whichever, or from shore, it goes to your storage tank, your double bottom tanks, and those tanks are basically down below, and you want to send this fuel from your storage tanks to your settling tanks. Now, aside from the effect of gravity, fluid do not move by themselves. It needs a force. It needs something to push it. So that's where this pump comes into play. So in this case, now we'll have what we call the transfer pump. The transfer pump now does the function of moving the fluid from that storage tank to your settling tank. That's, we've identified one pump. That's the transfer pump. Now we go forward. Your fuel is now in your settling tank. You can't use it from there because you have to drain all the water out and pass it through your purifier to remove the dirt, the water, and every other carbon content that it can purify and remove out before you can now send it to your service tank. So eventually, when this fuel has passed through your purifiers and all that and has been sent to your settling tank, sorry, your service tank, you still need to move it from your service tank round the system. If not, the fuel will not move itself because it's not a gravity system. So for you to move the fluid around your system, through your filters, your heater, around the whole entire system up to your fuel injector, something must move it from that service tank around the system to give it that push. So that's where the supply pump comes into play. So now the supply pump is what transfer the fuel from the service tank through your filters, round through up till the mixing column. Now when it gets to the mixing column, the transfer, it's more like, let me put it like this, it's more like for every stop where there is a tank, where the pressure, where there get to be a break in pressure and a settling of the fuel, more like a tank scenario, you must need a pump to continue the movement. check from the beginning. We have a storage tank. We need a transfer pump to move it. We now have a service tank. We still need a supply pump to move it round. The name supply means it comes from the fact that it is supplying the fuel, it is taking the fuel round through the system. Now we get to the mixing column where the fuel is, where air is supposed to be vented out of the fuel to avoid airlock in the fuel oil system. You see that that's another tank. So we will need a pump also to move that fuel from that particular spot, because as it goes there, the pressure reduces. The fuel may not have that sufficient pressure to keep going round. And we should understand that this piping system are not just one straight line, that it will just be going in a linear format. Most of them are curved, most of them are crossed. There's lots of design. So in this mixing column now, we also need another pump to move it. That's what we call the circulating pump. So the circulating pump basically tends to maintain the pressure in the system. Where the pressure from the supply pump stopped, the circulating pump takes over. Most books call it the booster pump. It moves the fuel from the mixing column through the heater, and through the heater to the viscotem. The journey continues through the filter. Now you get to the last stop, which you see from this diagram is called the fuel pump. Most books call it fuel injector pump. So now the fuel injector pump, unlike every other pump, is a high pressure pump. Its duty is not just to move fluid about. The transfer pump moves from one point from storage to settling. Service moves round the system. Circulating or booster pump tries to maintain the pressure and moves it from the mixing column. But in this case, the fuel injector pump is a high pressure pump that injects the fuel or atomizes the fuel into the engine cylinder. Why does it have to be a high pressure pump? It is a high pressure pump because for anything to enter into the combustion chamber, the outside pressure must be more than the pressure inside. It's more like me, I want to open a door and I don't have a key, and the door is not properly locked, and somebody is inside pushing the door from opening, and I am standing outside trying to push the door to open. Now you'll see that if the force that I have from outside is not enough to overcome the force of the person that is inside, the door will never open. So the pressure I'm applying outside must be great enough to overcome the pressure of the man inside trying to counter my pressure. So that's exactly what the fuel injector pump does. It pushes the fuel in a very high pressure in the pressure, so that it overcomes the pressure inside the internal combustion engine and inside the combustion chamber rather, and atomizes the fuel for combustion to take place. So we have the 4 different pumps in a fuel oil system before the fuel is being atomized into the engine by the fuel injectors. So there's a transfer pump, there's a supply pump, the circulating or booster pump, we have the fuel injector pumps. All of them have their unique functions, and if one of them is not there, then there is a problem. The engine or the system cannot work properly. I hope you enjoyed today's session. Remember to subscribe, remember to like this page, share it to your friends and family, and yes, I really want to hear your comments. See you again until next section, until a space. I remain your host, Engineer Dorcas Jonah.